Okay, today we'll discuss about the topic atomic structure and chemical bonding. And what we'll do is we'll discuss about Bohr model of hydrogen atom. And before going to that Bohr model of hydrogen atom, we'll discuss about the experiment conducted by Rutherford. It was called a gold foil experiment, and he introduced a model of atom, and with which we are very familiar. It is equivalent to the solar system. So this was your solar. Here you have the sun, and the planets are revolving in orbits around the sun, just like that. Here you have the nucleus. The electrons are revolving around the nucleus in certain circular paths called orbits. And all we are familiar, there are certain difficulties or there is a failure of this model, and it is nothing other than what happens is the electron will finally fall into the nucleus. This was the electron which start spiraling into the nucleus. That means the Rutherford's model could not able to explain the stability of atom. That was the main drawback. So there's a man called Niels Bohr. Niels Bohr, a Danish physicist, was studied in Rutherford's laboratory since 1912, and he successfully explained the spectrum of hydrogen atom and presented Bohr's atomic model. And he could able to explain moreover the stability of atom also. So we'll come back to the spectrum of hydrogen atom later as the discussion progresses. For the time being, we'll discuss about the major postulates of Bohr's model of hydrogen atom. The first one, electron revolve around the nucleus in definite energy levels called orbits or shells, and in an atom without radiating energy. That means whenever the electron remains in a particular orbit, it won't lose or gain energy. As long as an electron remains in a shell, it never gains or loses energy. Then the gain or loss of energy occurs within orbits by only due to jumping of electron from one energy level to another energy level. Whenever electron moves from a higher level to lower level, it will emit energy. But in order to move from a lower level to higher level, it will absorb energy. Hnu is a form of energy. So in order to move from a lower level to higher level, it absorbs energy. But from higher to lower, it will emit energy. So this is the next postulate of Bohr model. Then the next one, the angular momentum mvr, mass into velocity into radius of an electron, is equal to nh by 2 pi, where n is the orbit number 1, 2, 3, etc. 4. See, what he says is the angular momentum of an orbit depends upon its quantum number n and its integral multiple of the factor h by 2 pi. So thereby he used a term angular momentum is quantized. That means in a particular orbit, the angular momentum should have a specific value. The term quantized means anything having a fixed value which does not change with the time, and that term is called a quantized. I repeat, anything have a fixed value which does not change with the time is known as quantized. That term is called a quantized. So angular momentum is quantized means, what is the angular momentum actually? The momentum possessed by a revolving body. കറങ്ങിക്കൊണ്ടിരിക്കുന്ന ഒരു ബോഡിക്ക് കിട്ടുന്ന മൊമെന്റത്തിനെ വിളിക്കുന്നതാണ് angular momentum. And what he said is the angular momentum of an electron is equal to nh by 2 pi means, see, for first orbit it will be h by 2 pi. For second one it will be 2h by 2 pi, that is h by pi. Third one 3h by 2 pi. So as long as electron remains in the third orbit, the angular momentum always is 3h by 2 pi. So angular momentum in third orbit is quantized because it is having its own specific value. While that in the second orbit will be h by pi. So the angular momentum in a particular orbit will have a specific value. That's why we say it is quantized. Okay, anyhow, see, we'll continue with the topic hydrogen atom spectrum in the next lecture. Okay, thank you.